Hi, I'm Medyk3D and today I will check if ZillaGrip works. Obviously it works, but is it worth it? For testing I will use PETG, Nylon, ASA and PLA. I think that should be enough. I've designed similar item to the one Tom used in his video about different kinds of beta adhesion liquids. Check the video here. And now I will check the efficiency of ZillaGrip. For this I've got this syringe. I will use about 5 mm of ZillaGrip. Place it on the FlexPlate. I've created the grid. Each line is 5 cm apart. I will use 5 mm of ZillaGrip, and in this way we can check the efficiency. For printing with ABS we are supposed to make 2 layers, but for printing with PLA we are supposed to use only 1 layer and thin with acetone. So it obviously depends on what material are you printing with, but let's just check one single layer of ZillaGrip. Okay, now I have 5 ml of ZillaGrip. I will put everything on the FlexPlate and check how much surface I can cover with it. So, okay, the ZillaGrip is dissolving the marker, so this is not good news, but on the other side, I was able to cover the whole plate. This is 220 mm by 220 mm FlexPlate from Medyk. According to the instruction, I should cover this way first. Yeah, and you should use ZillaGrip in well-ventilated room, because it really stinks. But this is okay. I would say that 5 ml of ZillaGrip is enough to cover about 20 by 20 centimeters area. Now I need to wait and apply the second coat.
A few moments later.
The first layer is dry, so I will apply the second layer going this way, and then I can start printing. I guess that I will use ASA as the first sample. It doesn't look nice, but hopefully it works. Before printing with ASA, let's check my printer power consumption and do some math. I connected a wattmeter and set the bed temperature to 0, 50 and 90 degrees C for 10 minutes. And this is the power consumption I got. To check when ZillaGrip is worth using, let's make some assumptions. ZillaGrip price is $29.95 for OZ, and let's keep it metric and sane. It is about $0.252 per 1 milliliter. In my test I used about 2.5 milliliter of ZillaGrip per one print. According to this website, 1 kilowatt hour in USA costs on average $0.1319. Power consumption of 10 minutes heating to 90 degrees C is about 0.01 kilowatt hour. So for 1 hour it is about 0.06 kilowatt hour. What is the sweet spot? Let's gather all the data. One print requires 2.5 milliliters of ZillaGrip, which is equal to $0.633. For this price you can buy about 4.8 kilowatt hour. This is equal to 80 hours of printing. But it's not only about kilowatt hours, it's also about reliability. If you are printing a really big part which takes 80 hours or more, it's about 2 kilograms of plastic to melt, depending on your setup, obviously. If you're printing detached from the build plate due to a bad bed adhesion or power outage mid-print, you can lose tens of dollars in the filament itself. FlexPlate from Energetic is about $20–30. This is almost as much as one bottle of ZillaGrip, which should last for about 40–50 prints. I'm not sure if such a comparison makes sense, but maybe it will help someone. In my case, the FlexPlate was included with the printer, so I did not take it into my viability calculations. This is my first attempt of ASA printing. is the second ASA print attempt. This is Nylon test print. This is PETG test print. So far I've printed with ASA, Nylon and PETG. As you can see here, Nylon has a quite severe layer shift, but it was because I did not clip my FlexPlate to the heatbed. And the ZillaGrip worked perfectly. It is almost flat, only the sharp corner lift a little bit, but for the Nylon it is really nice. So far I got the worst results using ASA, which is quite strange because Nylon printed okay. The first test print was like banana, and the second was a little bit better, but it is still not good here and not good here. I assume that when using the advised Brim settings, it would print just okay. I don't know if it's because of my nozzle temperature or something, but I expected ASA to behave the same as Nylon. Anyway, I was able to successfully print using ASA, using the settings advised in the manual, and it prints just fine. Now it's time to print with PLA. It should be an easy task, but first I would like to remove the remaining ZillaGrip and apply the really light coat. Hopefully I will be able to get it much smoother than the one I've applied in the first go. But first I need to remove this remaining ZillaGrip, and I assume it will be quite a painful task. You know what? I think that the scraper and razor blade would be much better. But I think that for PLA, I will leave it like so and just touch this place and this place and check how it works. I don't have much time to scrape it perfectly. Let's see if ZillaGrip can be dissolved with acetone right on the FlexPlate. Did I say that you should always use ZillaGrip in well-ventilated area because it stinks like hell? Ugh. I think that the FlexPlate is ready. This is a really thin coat of ZillaGrip. Now I need to change my filament from PETG to PLA, and this will be the last test. Let's go. This is the PLA test frame. In videos about ZillaGrip, I haven't seen that anyone was using steel FlexPlate, and as you can see, it works also on this surface. The manual says that in order to remove the print, you should heat the bed to 90 degrees C and then use a razor blade and some kind of spatula to remove the print, because then the ZillaGrip is more flexible and now is kind of hard. But with the steel plate, I am able to use the spatula like so and just remove the print. And so far, this is one of the main downsides of ZillGrip. First, you need to heat your heatbed to 90 degrees C, which is quite hot. And then you need to use sharp object to remove the print. Be extremely careful there. The downside of removing the object from the cold steel FlexPlate is that you are taking the whole ZillaGrip with the print. Normally, while using the method from the manual, most of the ZillaGrip stays on the heatbed and you just need to retouch some small pieces and you are ready to print again, but it is okay. And to prove that this really works, you can check this print. This corner was printed here when there was no ZillaGrip, and as you can see, it peeled off because it was printed like so. This whole area was not connected to the FlexPlate. But here was the ZillaGrip and it worked just fine on the cold FlexPlate. This is really quite impressive. The last check I would like to perform is whether I am able to remove the test object from the FlexPlate without the help of any sharp objects, because it can be dangerous. So let's check it. As you can see, it is pretty flat. The sharp corner here is just slightly curled, but I think it would also happen to the regular PI sheet using heated bed, so it is really nice. Let's check if I can just flex it. And it works. The bottom surface is pretty nice. There is no leftover of ZillaGrip in the case of PLA, but the texture is not perfectly flat like on glass or something. But the test piece came out great. This test piece was printed using PETG and it came out great. There was no lift at all, maybe just a little bit on this sharp corner, but it is expected. Normally you would just add a brim around here or something and it would be good enough. But I would like to remove this ZillaGrip's residue from the bottom side. And there are two ways I can think of doing so. The first one is to use sandpaper or something to scrape it off. And the second one is to use acetone to dissolve it. By the way, while using acetone on your self-healing cutting mat, be extra cautious because, as you can see here, I've already removed my markings there. This is acetone. Let's see how it works. Yeah. So in case of PETG and PLA, you can probably use this method. But if you are printing with ABS or ASA, then it would also melt the part itself. So maybe consider using rafts or something if you want to get really nice bottom surface, if you really care about quality of your bottom surface, because the bottom surface is really nice. It's really flat and it was shiny. But it doesn't look that good with all that ZillaGrip residue. I will add some more acetone and check how good it can be. This is the result of removing the ZillaGrip residue from the bottom side using acetone. It's kinda okay, but it's not perfect. The ZillaGrip can be seen in some places because it was not perfectly even on the heatbed and it is embedded into the plastic, so it will be quite hard to completely remove it. It probably would be better to just paint it or be cool with how it looks. The summary is quite obvious. ZillaGrip works just as expected, and it works really great if you follow the instructions. So read the manual and follow the instructions and you will be fine. The biggest downside is that you are supposed to use a brim. I don't like brims. What's more, PrusaSlicer doesn't like brims. Brims in PrusaSlicer just don't work. In the manual it is said that you need 2-layer 20 to 30 loop brim or 2-layer double 15 ring brim, and PrusaSlicer is not capable of doing so, so you just need to add a custom object, make the height of this object to layer height and make it big enough so you can cover your printing object, and then set the perimeters to a lot of nines and you are ready to go. Caution from the manual: use in well ventilated area until dry. Very true, it stinks like hell. Be careful with sharp objects and around high temperatures. Use common sense. Those are my test pieces. I also printed some custom parts using the recommended settings and it worked just great, so following manual is always a good option. For the testing pieces, the first one is this one. This is ASA from Tarfuse and it worked like crazy. The filament is a little bit wet, it can be seen on the surface here and I could hear the popping sound while printing, so I should probably dry it, but this is not acceptable. So then I've tried the second time and it was a little bit better, but it's still quite a lot of curling in here, so you probably just should add brim around it and I am sure that it will be good. Nylon is the biggest surprise for me because it printed almost perfectly flat. The sharp corner lifted just a tiny bit, but this is nylon and it printed perfectly. I was able to make a spectacular layer shift in this because I forgot to clip my FlexPlate to the heatbed, in this case the cold bed. This is the PETG testing piece and it came out great, really nice. And those are PLA. This one has wrong Z offset height. It was a little bit too high. It can be seen here on the first layer and it just didn't stick. This was the second one. It was better, but the Z offset was still not perfect. And this is the third one. This is just perfect. The Z offset is just right. And only the smooth curling on the very edge of this really sharp corner. Do I recommend the ZillaGrip? Of course I do, but you need to know the limitation of this magic liquid. So, for me the biggest downside is that there is a leftovers residue on my prints, but for PLA there is nothing. There is nothing. This is perfect. And I was using the FlexPlate. I haven't seen anyone doing so, so maybe I am the first one, correct me if I'm wrong. As you can see here on this PETG sample, the first layer has some ZillaGrip residue embedded. And this doesn't look that good. The surface is quite smooth. I was using acetone to remove the leftovers, but was unable to remove them all. In my opinion, if you are printing really big objects for a long period of time and there is a possibility of power loss, the ZillaGrip is really worth it. But if you are more like me and you are just printing small parts, like for 1 hour, 2 hours, your biggest print is like 7, 10 or maybe 12 hour top, then the ZillaGrip, maybe not so useful. Because applying ZillaGrip is quite a lot of hassle compared to just wiping off your build plate with IPA, but for the long print it is really worth it. Watch my other videos that are right here and here. I jeśli jesteś z Polski i chciałbyś wypróbować ZillaGrip, to daj znać, to ci wyślę jedną butelkę, bo nie wiem co z tym robić w sumie. Tak.